I'd like to welcome you back to our second panel for the NITRD Symposium. And I'm Bob Bonneau, and I have a number of hats, but I work for the Chief Technology Officer for the Department of Defense. But I also am a co-chair of the Large Scale Networking Group. And I see a lot of familiar faces here, which is great. It's really great to see everybody kind of come back. So we're gonna talk about networking and security, and I have a great panel with me today. And I'm gonna briefly introduce them, and then I'll have them sort of talk about some things of interest to them, and then we'll just jump into our discussion. So I'd like to introduce first Deb Frankie. She's the National Security Programs Associate Labs Director for Sandia National Laboratory. And she was the Associate Laboratory Director for National Security Sciences at Oak Ridge National Lab. Before that, she was Director of Research at NSA. And she's also a professor at the University of Idaho. And Jim Carosi is the Distinguished Professor of Information and Computer Sciences and Associate Chancellor for Partnerships at the University of Massachusetts Amherst. And he was also NITRD co-chair, and that's when we worked together, so it's great to have him back. And then Chris Ramming is the research director at VMware. He formerly was at Intel Labs at their University Collaboration Office. And then Chris and I also worked together at DARPA, where he was doing mobile and ad hoc networking research. So we're gonna jump into this topic. There's a lot of really interesting things to explore, so I'll just turn it over to Deb to kind of give a few thoughts on what she'd like to talk about.
Thanks for that. It's so much fun to be here, I have to say. It's a little bit like Old Homes Week to come and see, although it's a bit frightening, I have to say, to have a 30-year anniversary of something that started after I had my first work in cybersecurity. So thank you for reminding me of that time frame there. I appreciate that so much. What I thought I would do for you is personalize this a bit by giving you a minute and a half or so of the top 5 things related to security and networking that are unclassified that I've done in the last few weeks that probably wouldn't have been possible when NITRD was first instantiated. So one is probably the easiest. There have been so many conversations in open public spaces about cyber warfare and the participation of civilians and the importance of critical infrastructure protection. This is a conversation we talked about either in hushed tones in enclaves or else just wildly speculatively in academic environments. And now it's a topic of public conversation, and it's just clearly a fact of what's going on with the changing face of war. Second one, an ongoing issue that we're having, and this one I have had many conversations over the years, has to do with medical devices in classified facilities. So more and more, not yet me, but someday probably, of us have got devices that we require for our health, safety, and well-being. I'm not just talking about my Fitbit, which is great for my mental health and my ability to count steps and move around. I'm talking about things embedded in our brains, things embedded in our bodies. Some of the top cyber researchers and other kinds of researchers in the country have got these kinds of embeds. They have often got Bluetooth enabled. This is a problem if you're working in a classified environment. There's an ongoing, continued consideration of how we can make this not security by waiver, but security in other ways. And so that's another conversation I've had in the last couple of weeks. Networks, cybersecurity. Third one had to do with my new job. So my new job has to do with what we do at Sandia. Sandia has launched more rockets than anyone but NASA. I've worked in terms of testing. And so I've had to learn quite a lot about that because I've largely not dealt with that frame of things. So I was out looking at our testing facility, and it turns out there's a really interesting, again, related to networking issue, related to telemetry. So if you're gonna take something really fast, slam it at a wall for ballistics testing, and you wanna get telemetry from it, you don't wanna do that with a wire. Because it's not going to survive the speed or the crash. And so how are we going to be able to get telemetry when the telemetry itself is sensitive? And we have to get that real time and streaming and be able to analyze it. That's a trick. Third one, so this is more personal. So I recently, again, as I mentioned, moved, and I personally like to keep some time invested in fitness, but I hate staring at a blank wall when I'm on my exercise bike, so I think some of you are with me on that. So what I've done is I've invested in an Oculus headset, virtual reality. Thumbs up, that's great. that was all working very well until I moved outside of town. So I'm now part of the rural community, and my original connection was a dribble. It was what used to be fantastic. 1.5 meg would have just made anybody's eyes pop 30 years ago if you could even find someone who had that wasn't direct wired. But that's nowhere near enough to run my system. And so I had to allow someone physical access to my home, to my internal wired network, in order to get satellite brought into my house and connected up. I have no way to check any of the antecedents of any of these parts because this is my personal home. I can't access what I've got in the lab. And I've got all this interesting technology that was brought to me just by connecting to the internet. So those are just a few of those things that have been happening now that would not have been possible before. Pluses for us in terms of how we live, but boy, the cybersecurity implications and the difficulties for national security and the implications there are tough.
All right, Jim.
Okay, great. Well, let me say also, it's really wonderful to be here. And I want to start off by, again, saying happy 30th birthday to NITRD. Like Deb, I remember the High Performance Computing Act, and I remember when NITRD was formed. And so it is sort of weird to be around for somebody else's 30th birthday when you were pretty old when it started. But I want to say happy birthday. And I wanted to give a shout out in particular to some of the NCO directors who I know are here. So we've met Cami, but I see George Strawn here, who when I was at the National Science Foundation, Bob mentioned that I co-chaired NITRD, but really the work is done by people like George and Cami. Keith Marzullo, I think, is here or going to be here today also, and the fabulous NCO staff. I mean, what NITRD has done, as we heard in the previous panel, and I think as we'll hear throughout the day, has really been fabulous and been wonderful for the nation. So I wanted to give a shout out to everybody for that. So my research area is networking. It's not security, but the two are certainly intertwined. And when I think about sort of looking back 10 years and looking forward 10 years, when I think about networking and what's happened and where it's headed, I think primarily about software. So everybody's probably heard about software-defined networking, but I think if I look back over 20 or 30 years, I think that's one of the most important things that's happened in the networking research community over that period of time. And I think SDN also tells a very compelling story from a NITRD point of view in particular, and multiple agencies being involved there. And since I was involved in some of that, I sort of saw some of that happening firsthand. So, SDN is going to be is critically important in being able to provide more flexible, more scalable, more evolvable, more open for innovation software, data, and control planes inside networks. First the wired internet, now much more even in mobile networks. And when I think about the origins of that, it hasn't been around that long. You can really cite the nexus of activity that really launched that to some folks in the Bay Area, particularly around Stanford University in the 2007, 8, 9 timeframe. So the National Science Foundation funded an expeditions proposal at Stanford University that Nick McEwen was the PI on, and there was also an NSF fine. So Yeda Mitra, I don't know if she's here, and Darlene Fisher were the program managers who funded that. NSA was interested in software-defined networks, particularly because of call admission and capabilities-based architecture that you could implement there and do that in a much more controllable way. And of course, DARPA was involved in active networks, which in some ways helped set the table for that. And now coming back and looking how software-defined networking is now moving into a data plane as well, and P4. And so, kudos to Dave Tenenhouse 25 plus years ago, and Jonathan Smith, who was one of the PIs on ActiveNet. I was too. And Jonathan Smith, who's been a program director at DARPA, sort of pushing that forward. So you see that multiple agencies have come forward. I'm not quite sure how carefully they partnered together, but they all knew what each other were doing and really lay the foundation and support the foundational research for something that has really rocked the world of networking. And so, again, when I think about the future of networking, S and SDN stands for software. And Mark Andreessen wrote this amazing editorial now 10 years ago about software eating the world, and that's definitely what's happening in networking. And I heard a quote from Nick McEwen that I'm going to read verbatim because for me it really, it shocked me when I heard it, but I think it's absolutely true. So I'm going to read it and then I'll turn things over to Chris. But Nick was talking about software and what that means for protocols, network protocols in particular. So he says we'll no longer think in terms of protocols and instead we'll think in terms of software. All functions and protocols will have migrated up and out of hardware and into software. And he went on to say, networking students, so I've written a textbook, so I think about this a lot. Networking students will learn how to program a network top-down as a distributed computing platform, and protocols will be described in quaint, historic terms. Now, nobody wants to be working on anything that's quaint or historic, right? Maybe 30 years later, you want to say, oh, I worked on that. Now it's quaint and historic, but there's a lot of work still going on in protocols and not quite so much in software. So I think that's going to be a real challenge for the research community. The last panel talked about education, how we're training people. I mean, working with systems, software systems at scale is going to be really, really important. I mean, it already is in some obvious areas, perhaps like in the last panel. It's also true in networking where 10 years ago, nobody, I think, really would have said that. So let me turn things over to Chris.
Thanks, Jim. So it's great to be here. An event like this is a really beautiful forcing function for sort of thinking back on where we've been and where we're going. And so as I sort of prepared for this conversation, one of the things that I realized is that this combination of terms, networking and security, is just an enormous topic. And it's partially because security itself in isolation is huge. You have all of the issues of confidentiality, integrity, authenticity, availability, and you have to think about all of those at the same time. And then networking is such an important underpinning of all of the compute we do today. And I think of compute, networking, and storage as being sort of three legs of a stool that needs to work together in order to make useful stuff happen. And so when we talk about networking and security, I think if you asked 5 people in this room, what they think of, they'd think of 5 different things. And Deb, you came up with 5 different topics earlier. So try it at a cocktail party, maybe tonight's reception. And so here's something that I've come to realize is that if you take an enterprise perspective on this question of networking and computing, you don't have the luxury of thinking about micro details like one aspect, say confidentiality. You don't have the luxury of focusing on one layer of the stack. You have to think about not just protecting the network, but protecting the users of the network and the applications and the systems. And so enterprises, whether it's a federal agency or some part of the DoD or a company somewhere, when they think about computing and security, they have to think about the big picture and balancing all of the details. And so what I think is interesting about NITRD, and we saw it in the tire track diagram earlier, is its role in helping have a conversation across people in industry, across government, across academia. And there are some themes that have been identified and advanced by NITRD over the course of many years that I think will be really interesting to talk about in a few minutes. And so, again, I would sort of scope back, take an enterprise perspective on what it means to think about networking and security.
All right. No, that's great. So I think we'll just jump right in with the questions, and then we'll kind of shape it as we go. So, okay, so I think what I'd like to talk about first is, what do you think the leading issues in networking are today, both from a design and security standpoint? What are the things do you think we really need to focus on? So I'll start with Deb, and we'll just kind of go from there.
I'll go a little non-traditional on this because I do think it's the human element. So I'm thinking about that from several different perspectives. When I started and when NITRD started, we could think about organizations, governments, corporations, identifying those particular specs of the network that they had, design carefully those aspects that would be brought into them, and then have purchased often government-designed components there. So a lot of control, still not perfect, but you had a lot of space. That is not true of the modern world. So another conversation I didn't give you is the hard conversations we're having about supply chain. That gets into the urgency with which we've got to have networks right now. I can't even function with my exercise routine at home without taking some risk. Corporations also, particularly with COVID, had to reach out to places that were not normal suppliers. Now, government also often could do a certain amount of checking for the backups. This is not so much true for private corporations. And so I think that one of the considerations that may not have gotten quite as much time in the modern networking is to not just build for, let's try to get the standards right, and let's work with adverse conditions. Let's think about where we actually do have networks that may seriously have been breached globally, not just locally. And how do we deal comfortably with that scenario when most of the people that operate them are not going to have the education or training or staff to look for anomalies or to fix things? They're just simply going to be working with what they've got. So that, to me, is the top part. How do we make, in essence, networks something that are safe and secure in an environment that I have to, as a security professional, consider compromised, and will remain so in a family-oriented workplace where I'm not firing the 2-year-old or the teenager or the guests that come. They're going to come and they're going to use my stuff. And how do we still function in that kind of a world? That's a much trickier problem than when I started cybersecurity.
Very good. Jim?
So panels are always great when panelists disagree. So I'm going to disagree with Deb. So
Right.
Deb just told you how important people are. And I will tell you that one of the most important things is getting people out of the loop, right? And in a software-defined networking perspective, if you think about systems at scale, right? And I say all that in jest. So whoever edits this, please don't just cut out that one thing that I said about it's all about getting people out of the loop, because it's not, right? But a lot of it is there are things at scale that you cannot have people in the loop on in large and complicated systems. And the history of networking and networking management, for example, has all been about these gurus who are going to go in and they type in, Cisco CL. Sorry, I shouldn't mention any names, but type in arcane languages and R shell into routers, and that's not the way to manage a network at scale and reliability. And one of the things that softwareization allows, and the logical centralization of networking function allows, is the ability to be able to do things computationally and to do them at scale. So in some sense, there are things that you want to take out of the network operator's hands, and you want to sort of raise the level of functionality that the people who are in charge of controlling the networks do, so that they can deal more at intentional levels rather than having to remember CLI and things like that and commands to type in. So I agree, it's all about people. In some cases, it's getting people out of the loop because computation is more reliable to do certain things than people or timescales. But then it's also about what's the appropriate role in enabling what people do best.
I'm going to ask for a reclama.
Oh,
Go
boy.
ahead, Chris.
So, what an interesting combination of comments. So, not 30 years ago, but 132 years ago, 1892, there was an enterprise computing and security problem. There was an undertaker named Alman Brown Strauger who noticed that he wasn't getting as much business as he wanted to. And it turns out that the other undertaker in town, this was in LaPorte, Indiana, had a wife who was a switchboard operator and diverted a lot of the calls to other people, to her husband. And so Alman Brown Strauger decided that he wanted to get humans out of the loop. And he invented a system for telephone dialing that was patented in that year. So, it's interesting to think about how security threats have evolved over time. That's an instance of a redirect attack, and you see that in DNS, you see that in BGP, you see that in URLs, and the technology has changed. And this is one of the reasons it's so hard to get a grip on what's going on in security, because the technologies change. But there are underlying themes. One of them is this concept of a redirect attack, and seemingly that's something that you have to think about for all networks. So you might as well think about that up front. And another one is deciding what should be in your chain of trust, which is the issue that Jim just raised. And we see echoes of that today in other forums like confidential computing, where people hope to use trusted execution environments to remove humans, or actually the network operator, from the loop. So there are some themes that are constant and evolving. And one of the things that NITRD has done is sort of call out capabilities that we want to have that sort of transcend the technologies and the themes. One of them that I think is really interesting goes back to the first strategic plan that NITRD did. And there was an idea that had been brooding about in industry and government and academia called tailored trustworthy spaces. And there were 4 themes that were identified in 2010 and 11 by NITRD. They built on work that was happening in academia, as I mentioned. There was the New Arch effort, a DARPA effort in the early 2000s. I think Deborah Estrin is here, and she was part of that, and Dave Clark and a bunch of others. There was work in the DoD, which was putting together the global information grid. They had identified, so that by the New Arch work that was interesting was called trust-mediated transparency, I believe. Trust-mediated transparency. And the global information grid was focused on policy-based controls that would be adaptive. And then there was a third group in industry, Cisco and others, who were trying to remember the name of it, the Jericho Forum, that were looking at what it means to have security in a perimeterless world. And NITRD, Doug Mon and a couple of other folks, Carl Landwehr, sort of got this zeitgeist and put it together and incorporated it into the plan. And that idea has continued to evolve. And today, one of the responses to COVID is based on some of the ideas that came out of NITRD. It's the idea of zero trust. This notion of zero trust, which is starting to play out in industry, is perhaps an example of the tire track diagram that's been emerging. And there are many companies working on this, and it's enabling societal opportunities. The COVID instance really pushed forward this technology and made it more real. And so I think one of the important themes here is sort of looking at the bigger capabilities and ideas that need to be achieved. And NITRD can sort of help promote those ideas as we move forward.
That's great. And yeah, I think, maybe we'll dig into the sort of, interchange a little more here. I don't mean to be a troublemaker, but okay, so what critical new research questions do we need to solve to address what you just described as kind of your key issues?
Yeah, I think in some sense we're all violently agreeing, but we're picking up the elephant by different parts of its body, and picking up an elephant is always difficult in any case. But the parts that I think are somewhat underserved right now do have to do with this balance, and it's not that nobody's worked at it, and some of this came out of the study that you just were referencing, that when Doug Mon scoped the United States essentially to find out what are the 4 or 5 components that we needed to be secure, and came up with his 10 elements for DHS and so on, is this combination of how resilience works in terms of being resilient to threat and how trusted design comes into play. And then I just have to put that pesky human back in because there is always going to be a human element. And this has been a bit of a hard realization for me, because I would have liked to have designed things secure from the beginning and made it easy, and we just hand you something and it's always perfect. But the nature of my job has led me to look at the corner cases. So in a war zone, a family looking to be reunited is going to take whatever cell phone they can find and try to reach one another. And they're going to set up a network to do whatever. In a disaster zone where you're trying to do something very quickly to get the word out, we now have great disaster networks in a box that will be very helpful, but that's not always going to be present. And so we have to realize that there are going to be times when people will, because of necessity, in order to take care of themselves, their family, their mission, they're going to do things that are a little risky. Sometimes it's going to be because of cost. So I was at a company the other day, and they were using a lot of really great technology, and one of the things they showed me was their reverse engineering of a Cubesat. And that was interesting for a lot of reasons. NITRD has been behind a lot of the research that went into being able to have such things as Cubesat. NSF and others in particular have been very helpful in making sure that this could become an academic investigation too, so that we don't limit space. And commercial world has used a lot of Cubesats, et cetera. So this is really, really cool. They were looking at networking for that. The reverse engineering, actually, one of the partner agencies of NSA, we released Ghidra, a reverse engineering tool. This company had built upon Ghidra. One of the interesting things that they found in reverse engineering that Cubesat to look at its security is they had, I won't even mention the origin, but it was a non-US company student license for MATLAB had functionality that was embedded inside of that Cubesat, and that was very old functionality. And they found something like 100 plus different CVEs, so vulnerabilities in that Cubesat and that network. And this was purchased commercially by an organization that believed that it would be fine just because the networking aspect was okay. I would beg to differ on the networking too, but in particular the endpoint, the Cubesat itself, was not secure. So this combination of resilience, designing security, and then recognizing that assumed breach, which is not exactly the same as zero trust, because I'm assuming that somebody has breached your zero trust solution or our zero trust solution because of cleverness or some need to handle it. So that human element, along with the technology, how do we broaden that and get that out to people in real communities who don't have the time, people in war zones who need that extra security? What is it that we're going to do in order to mitigate the after effects of an incident as well? We haven't even talked about privacy, and we ought to in that context in particular.
Very good.
So I agree with you 100%.
See, this is better.
But I will say, so certainly trusted computing environments, and I think one of the things, again, about the softwareization of networking is that it's bringing in other parts of computer science and also other parts of NITRD. For example, if you think about software, you think about, you want to do configuration management checking, and so model checking, programming languages are now really becoming really a key part of networking approaches given the importance of software. So I would say that those are all challenges. In addition to the challenges that Deb mentioned, that Cubesat's a really interesting and sort of legacy software that sort of gets incorporated along, I'll say one of the trends in software-defined networking is really all about open source and innovation, right? And so a challenge then is going to be, if you've got open source contributors and you're thinking about mobile packet cores that are now open source, or you think about open source for traditional routers, and you've got large communities of people contributing to it, it's going to bring up the question that you just raised many, many times.
Wow, so such a big question. I guess in terms of enterprise networking, one of the things that's interesting is that the whole environment is in tremendous turmoil right now. There are forces at work. One is 5G and next G, which is introducing new access technologies. And we have satellites, and we have all sorts of opportunities that didn't exist before at the edge. So now all of a sudden our security challenges need to extend all the way to the edge. And these are heterogeneous access networks and edges, and so we have to have true internetworking across technologies, which is kind of challenging. Meanwhile, hyperscalers and the large cloud computing companies are laying down enormous amounts of fiber and basically offering networks that can be used in interesting ways end to end. And so there's this sort of interesting struggle between networking technologies at some notion of a core and at the edge. And a lot of different sort of entities who are offering services and capabilities. So one challenge here is, how do you stitch all of those things together? And then how do you use them in a way that keeps the trust, the zones of trust as small as possible, which is one of the tenets of zero trust. And so people are talking about slices and overlays. And so this combination of a very heterogeneous bottoms-up set of networking technologies with the desire and the need to circumscribe and virtualize or control or slice or overlay those technologies in a coherent way, I think introduces all sorts of interesting challenges.
Mm-hmm. No, that's very helpful. So given that we are doing the NITRD Symposium, how do you think NITRD can enable some of the solutions on the research side that you just described? What do you think the sort of general strategy would be useful?
I'll pick on a couple of ways. There's just so many opportunities. One that maybe should go without saying, I'll say it anyway, is that by NITRD being a convening body with a lot of different technologies introduced, things at the research stage, we have the opportunity to drive security in and security thinking in at a much earlier stage than would be possible without. So for instance, Quantum is important from a lot of standpoints. We have the post-quantum world with crypt. There's also, what does one do to secure a quantum system itself? What does it mean to do quantum networking? Bio-inspired computing was mentioned in neuromorphic at the last panel. They're going to have different characteristics in terms of the kinds of things that it takes to make information secure. You're going to have different latency issues. You're going to have different kinds of computations possible. There may be very different kinds of crypt algorithms, not even getting into the quantum post-quantum world crypt, but what is a post-bio-inspired high-performance computing crypt look like? I don't know. I don't know how to design those algorithms. And so by pulling in the people that are funding those kinds of technology early and starting to have discussions about the characteristics of the devices, the networks, and the engagements, little n network here, need to make the whole system secure, that could be a huge contribution. Just getting those people together and thinking it through so that we don't have everything be like the internet now, where it's let's try to slap on some remedies that we probably could have added in, some of them, not all, 30 years ago.
So I'd like to answer your question, Bob, just a little bit indirectly, because Chris had mentioned the tire tracks diagram, and the tire tracks diagram was shown, I think, in the previous, either the previous panel or maybe in Cammie's opening, right? And I'll speak to the CI fellows in particular, because I imagine many of you haven't seen the tire tracks diagram, but when I was the AD for size at NSF, it was the graphic that I used all the time. There was discussion in the last session about the value proposition for research and how you tell the story about that. That graphic, the one that Cammie showed, was a little bit complicated. But if you look at it in pieces and you look back historically from the 95 version to the 2012 version to the 2021 version, it tells a very, very powerful story. What you see on the right-hand side of that are these tracks that have government funding, university funding, research and products, right? And you see these lines going back and forth. The story behind the tire tracks is how in the United States in particular, there's this amazing interaction between researchers in academia, primarily government agency funded, in industry, and the products and the services that arise from that. And every one of those little arrows going back and forth with time going up in here's networking, here's software, here's databases, here's graphics. Every one of those is a particular instance of an artifact, a person, a piece of software, an idea that's gone back and forth. And that kind of interaction, it's enabled, and those arrows go between areas. It's not just like all within networking, right? There's networking goes here, databases goes here, graphics goes here. It tells a really, really powerful story about what happens when you get that kind of collaboration between academia and industry, academia powered by government funding, and when you get these synergies across areas. The director of the National Science Foundation, when I was there, France Cordova, when she went to, I think it was probably 2018, to Congress to testify about the budget, the single graphic she took was that tire tracks diagram, because it tells that compelling story about the value proposition that we were talking about. I think NITRD plays a key role in bringing together the players. There are other organizations that help bring together these key players as well. But I think that story, that interaction is really, really powerful to answer some of the questions that came up in the last panel about being storytellers and talking about the value proposition.
That's great.
So as soon as you mentioned tire tracks, Chris, I was like, oh, there's something I want to say there. So
it's a great diagram, and it really, it is so interesting to look at all of the instances in which ideas have bounced between academia, government, and industry. And so I think, Bob, you asked, like, what are the most important technologies? I could pick one, like, confidential computing, because it changes who's in the chain of trust. And that's a really interesting, powerful idea. But I think the role of NITRD might be much bigger than that. It's about identifying these capabilities and these themes, ideas like these notions around zero trust, and really getting people to come together and do something. So the role NIST has played in that particular story, for example, in really codifying best practices and so forth. The role that DARPA and NSF played in advancing some fundamental research. The role that several companies played in actually making products and building stuff. I think maybe it's not about NITRD promoting gaps or opportunities, but about being the storyteller. and being the organization that sort of helps bring all of these ideas together.
No, that's great. I mean, and it's something we talk about in NITRD all the time, you know, so it's very, very helpful. All right, so now I'm going to shift gears a little bit and start thinking on the academic side. So if you imagine that, you know, these are our objectives and we've kind of got them all laid out and, you know, we're sort of going in the right direction, how would that translate to specific academic disciplines that we need to sort of enhance or, you know, sort of inject new thinking into in the way we sort of teach these things, so graduate students and others coming out actually will be prepared to you know, address what we're trying to describe as these sort of new research frontiers. So, yeah.
Well, there's of course the core disciplines, and so I'll set those aside because we know where those are. Some of the areas where I see the bigger lacks have to do with how people think about security. So for a lot of my career, I think I fell prey to this as well. We thought of security as a wall that goes around things, and really what I've come to pivot and think about is security as an enabling function, an enabling capability. So design security in so that you'll be able to do these things more safely, so that you'll have more confidence when you take risk. And what that argues for is both transforming how we talk about security and then taking it into places where people are going to be taking risks. So for instance, health and safety, those professions. So anybody going into medical really needs to understand the implications of putting a medical device in someone's brain that has a Bluetooth access on the outside. I'm sorry, that's critical. Anybody using artificial intelligence needs to understand sensor blinding at some level. They need to understand how to ensure that it's not bias in, bias out when it comes to our algorithms, because that's also insecurity in, insecurity out. By that I mean, if you don't understand the representation of your demographics, and if that's not in the data set that you're leveraging, you're not going to get the outcome that you wanted. Mm-hmm. So it's this broader thinking about how does security fit? And then just everything's going to be networked. So I don't know that everyone can learn the protocols, but really understanding at least some aspects of what needs to be present in the broader discipline. So STEM, it's a little clearer. What do we design in for people to do their jobs and work on the problem specifically? It's the non-STEM, the STEAM aspects, I think, and the broader business community and what we do in our daily lives. That's the part that I think needs the most work done so that we can take advantage of the great tech that I suspect the two of you are going to talk about next.
Well, actually, I wasn't going to talk about the great tech. You know, you strike me as a humanist. I mean, you were talking about people and society and use, which is the right thing to be talking about. And so I think that when I advise both undergrads and graduate students, you know, especially as they're working sort of higher up the protocol or higher up the stack, if you will, and more in applications. And if you think about anything in human-centered AI or what you were talking about in health, you have to understand people. So I see phenomenal amounts of collaboration needed between the social sciences in particular and computer science. I know at the National Science Foundation, the SBE and the SCIES director have been pushing for years for more and more collaboration and announcing joint programs together. So I think the people aspect of computing, because that's, you know, in the end, that's what a lot of what we do is about, is really important. I agree with you. And then there's sort of the underlying technology students need to study broadly. And maybe I could just take that, the issue of education in a slightly orthogonal direction, but it's about education and it's about where we're doing the education. NSF has been talking about enhancing and growing the geography of innovation, right? And that means that enabling innovation really across the country in many different ways, and education is a key part of that. And you know, I think that's something, education was talked about in the last panel as well. I think that's something incredibly important for the country, and something that really has to pervade the community college system, the state system, the privates, and the public research universities as well.
So Ben Zorin mentioned the Computing Research Association has this new group that's looking at industry academia problems. And one of the, you know, if we take an enterprise view on what needs to get done, it's about the end-to-end system and how all the pieces work together. And what we've observed is that the cloud is a place where all of the pieces come together and people can build end-to-end systems that need to be secure and usable. But the discussion that we've been having in CRA industry about the cloud touches on education. It's this enormously important capability that underpins a lot of important applications and workloads these days, but it's a black box, and people can't get into it to tinker with it. And so one challenge for education might be to expose that kind of capability and find a way for people to sort of get into the insides, understand what's going on, build on it, expand on it. So the kinds of things that could be done in academia, Kathy mentioned Cloud Bank, which gives people access. Could Cloud Bank be not just an accounting interface, but a platform for conducting research in cross-cloud applications, or exposing interfaces that can be used to researchers by the cloud companies? So one direction might be to do that kind of thing, and another direction coming from the top down might be to sort of pay a lot of attention to things that transcend individual instances of a cloud. So opportunities around sky computing that are being explored at Berkeley, or the extensible internet, where we look at new ways of embedding functionality into what people complain has become an ossified entity. Those are directions that perhaps could be very interesting.
Very good. All right. And so now I'm going to sort of be a bit more expansive about this. So I guess we're looking sort of to the future, and I guess I want each of you to sort of tell me what you see the next trends in networking and security are going to be in the next 10 to 15 years, which is a long margin for this. A lot of stuff happens in a couple of years, but see if you can, whatever you can prognosticate.
Yeah, I've learned it's probably not a good idea for me to prognosticate too much, because either A, people listen and do something wrong with it, or B, they don't listen and I'm just sad. But I do think the truth lies somewhere in the conversation we're having about newer tech. So this is and to regain my STEM credentials, I've been able to lead or been part of most every interesting tech, from AI to hypersonics now, non-proliferation, cybersecurity, computer science, high-performance computing, and so on over the years. And so what I see is that we're at this really cool time when we've got new software architectures, new hardware-software combinations coming forward, and new ways of thinking about programming and operating systems. So there is a tremendous opportunity. I wasn't kidding when I said I don't know what protecting a bio-inspired computer really looks like. I could tell you how to encapsulate it, but what does it mean to design security in? What does it mean to design security into a quantum system as opposed to using it in security areas and to put boundaries around it? What do those things mean? And so I think if I'm talking to the graduate student part of the audience and the fellows, as opposed to industry that needs to capture something that we already know about now and bring that to market, I would say look there. What are those new technologies that you think would have a great societal impact? And how could we design security into those networks and the devices to enable and empower people to do things that are more secure, more beneficial to one another, with less risk than what we've done in the past? So that would be my challenge for this broad going forward.
Well, again, I mean, for me, the challenges are all around software and the softwareization. I want to come back to Chris talking about the hyperscalers, and when I think about the education that we in universities deliver to students and what we're able to do or not able to do, say, at scales that really that the hyperscalers are dealing with, I think that sometimes there's a challenge for us, especially in software, especially with data, especially when you think about the geography of education across the country, not having access to those kinds of systems and tool chains and things like that at scale. And so I think the software at scale is still something that and then again, this is primarily from an education standpoint rather than a research standpoint, I think that's going to be a big challenge for us as a country. And you talked about Cloud Bank. I mean, that's an opportunity there, not just to be a resource for cycles and data for the research community, but also for educational tools. And I know that the Cloud Bank people have had discussions about that.
Mm-hmm. Well, I sort of going back to this tripod of processing and data and communications, the network has always been something, an important resource that's pivotal to so many things that we do. We have to protect it. But it's also this control point that gives you purchase on helping with security in the other elements. And so it's gotten a lot of, network security has gotten a lot of focus. But I wonder if it wouldn't be interesting to turn around a little bit and focus on the data that is underpinning all of this. And so, data has been characterized as the new oil, and it's very important. But we haven't really gotten a grip on how to transmit it, share it, and retain control over who gets to do that. So one of the reasons I was excited about confidential computing is that it closes one of the loopholes in a lot of the data use controls issues. But maybe it would be worthwhile to think about focusing a little bit on data security and not always on network security. Because if you start with that foundation, it might enable all sorts of new opportunities. I was really interested in the White House's idea of, or the OSTP group, talking about democracy affirming technologies. Mm-hmm. And if we could really get better control over our personal data, over our corporate data, and share it with confidence that it's not just regulations like CCPA and GDPR protecting it, but really there are technological underpinnings that let us retain that control over who we are, who we want to project into the world. That could be a very exciting opportunity.
Very good. All right. So I think yeah, we'll go with one more question, and then I'll open it up to the audience and the folks online. So I guess my final question is, how can we sort of increase the number of opportunities for both qualified academic and professionals to sort of get into the space coming up, like either at the secondary education level all the way up to the the higher education level. Like what do you think a strategic way to get more opportunities for people to get into this business?
Well, I know it's always tempting to say more programs, but I'm still going to say it anyway, because I do think that we need more and different. The future, a lot of it is around big science. And to me, when I think about big science, programs that send people to the national labs to come and work there and to get to work on the high performance computing directly, to go into the labs that are looking at next generation advanced manufacturing, to think through what does it mean to do quantum in a secure way. All of those different challenges. And it can be difficult. The labs tend, and also government agencies that have those opportunities and industry that has those opportunities, you need a certain level of qualification, a certain amount of vetting of people that come in. And I'm not talking about security vetting so much as do they have the background to be able to be effective and to be effectively served by that opportunity. So thinking through what are the kinds of programs that have made sense in the past and applying them to the future. There's a couple I'll point to, 3, I think, because NITRD and NITRD organizations have been part of these. Center of Academic Excellence program, the DHS and NSA collaboration there has been fantastic. There are now many certifications and hundreds of institutions qualified to teach cybersecurity, and some of those are quite broad. There are programs through the Department of Energy that are bringing scholars in to work on some of the top technology we've got in this country, and I think taking advantage of that, NITRD could perhaps help in some of the discussion of that piece. But what's perhaps underserved are those people with the background that doesn't enable them to take advantage of those things specifically. So how do we get at the rural communities, the kids that haven't had that opportunity, that have that 1.5 meg connection that I had when I first started? I was able to take advantage of having a paycheck to go ahead and buy my way out of that problem. But that is not an option for all. So how do we get that rural connectivity? That's where I'd like to see more focus, to get more engagement and then have people find an easier way to take advantage of the right opportunity for them where they are so that they can advance and use that for the good of all, really. Because we're going to need people. There's the one thing that's common to any conversation about cybersecurity and networking is we do not have enough people who have the background to meet anywhere near 1/10 of the needs that we've got.
I'll agree with you. It's all about the people. And I'll agree with you also, it's about more funding. And I think I'll agree with you. I'm not quite sure you said this, but I'll put these words in your mouth. There's not a silver bullet, right? It's not like, oh, what's that thing that nobody's thought of that we should all do as a community, and then the sun's going to rise and clouds are going to part and everything's. everything's going to be wonderful, right? There's amazing programs out there. So Deb mentioned some of them. I'll mention, if you think about pipeline issues, the computer science principles AP exam and the way that's been able to broaden and fatten and diversify the pipeline of students coming in at the high school level. That's been really fantastic. Deb talked about the Security Fellows program that are funded. I think the money actually comes through the NSF, but it's the CAE Centers of Excellence that sort of provide the certification. So there's wonderful programs out there. All schools have been thinking a lot. I mean, every school is trying to build up its capability to teach students in this area and provide fellowships for students coming in. So I think there's a lot of really great programs out there. I'll give a shout out to all the people working in CS plus X and really trying to take computing and think about how it applies in all these other, many disciplines, a few of which we've talked about today. So I think the programs are out there. I think it is a mistake to think, there's a silver bullet that nobody's thought of, and if we just think about it a little bit harder, I think we just need to double down. We need to double down on the work. We need to double down on the funding for it.
Good. I'm just going to agree with the both of you. Cloud computing has democratized a lot of computing, and young kids today have access to things that I never dreamed of when I was like my daughter's age. But if it's not accessible fairly and equally through society, it's going to be a real shame. And so whatever we can do to make cloud computing more accessible and ensure that it's available to people who are interested in the area, that would be a good thing.
Excellent. All right. Well, I appreciate the discussion. Now I guess we'll open it up to folks here in the room and also online. So whoever would like to come up, we'll take questions. And just say who you are and where you're from, too.
Yes, okay. Hello, everybody. My name is Arun Balasubramanian. I'm an associate professor at Stony Brook, and I do networking research. I really enjoyed your conversation, especially about the education, because I do find that actually networking is not sexy. So people, almost every year I teach the course, they say, oh, I never expected this to be so interesting. But I had a different question, which was that there is democratization in terms of applications, but I find that in terms of the stack itself, things are becoming more and more centralized. There are companies that are essentially, they have their own WAN, they have their own POPs that they have all over the place. They actually recently even have a big control of the ISP. And I'm not making a value judgment here about whether that's a good thing or a bad thing, but I want to know what are the implications in the next 10 years for networking research and security research, given that this is what the trend seems to be.
Okay, I'll open it up to any of the panelists.
Well, I think this is one of the reasons that I'm interested in sort of multi-cloud and Jan Stoika's vision of cloud computing, because it can create opportunities where maybe they're opaque right now. And I'm also very interested in this extensible internet idea because it offers an architecture that even if things are centralized, you can insert new ideas and see them come to fruition potentially. So I think that we could make investments in ideas that maybe counteract or complement maybe some of the benefits of the centralization you're observing. Centralities are not good for security in general. So, so that is a consideration we might take into account.
All right.
I was whispering to Chris and Aruna when you asked your question. I was going to ask that question. I was going to ask Chris that question if we needed a question. I agree with you 100%. There's a writer named Tim Wu who wrote a book called The Master Switch, and it looks at the telecommunications industry, and it talks about over a history of 100 plus years, how it's gone from mostly centralized, regulated monopoly, broken up, coming back together, and it's going back and forth. And I see that happening with us in computing and computing plus internet, plus data as well. So I think that's part of a natural part of the process, and I think we just all need to be aware that this can happen and that we want to have some kind of diversity and we want to enable innovation really all the way across.
And I'll echo those comments and add one more. Because of the ebb and flow, we have a need to make sure that we can maintain the capability. Because part of the problem that you're pointing at is if you are, say, an assistant professor and you need to get data to do your research and you can't get that data, then you're either going to switch fields or you're not going to get tenure. One of those two things is going to happen, or else.
Or you'll go work in industry
or
where
you
you
go
get
work
the
in
data,
industry
right?
and get the data directly, and then we get you back later on. But I think there is a reason to deal with technological drought in certain areas, and that's possibly something that NITRD could keep an eye on. What are those fields where we need to perhaps elevate different kinds of computational networking resources? I don't say access to data set because that's a very long conversation that's trickier, but how one would get access to those things would help you learn and advance the field. Because you asked another thing, the downside, if we don't find a way to do that and we privatize too much, then we get homogeneous winners, which, as was mentioned, is not great for security, because one flaw in that and all bets are off.
Deb, can I just add one thing to you? Just build on what you said. You brought up data and access to
Yes.
data. And again, I feel like there's something very important that we need to look into how you give people control, because if they had control, it might be more accessible than it is today.
I think the data and the model, because we're now going to AI models, which is a little trickier, I realize, but you build a model on the data, and that model is not easy, but it is possible to reverse engineer it. So what is it we do to protect your control over the models that have your data as well as the data that you've got, which is not exactly the same thing, but related downstream. So ties it back to your question as well. Those things would not be considered in academia if you didn't have any way to get access to the tool and to the data that's being leveraged.
Very good. Thank you. Next.
Hi, I have a question. Oh, my name is Tara Zimmerman. I'm a CI fellow with the University of Texas at Austin. And going back to your earliest comment, Deb, about the human element in cybersecurity, I'm curious if any of you are aware of any initiatives to incorporate even the most basic cybersecurity education into like information and digital literacy in K-12 schools, because those are going to be basic life skills moving forward, and it seems like that would be such a great way to address that on a broad level early on and early intervention.
Yeah, there are some. I'm thinking in particular of one that was a collaboration between NSA and NSF, and it's called Gen Cyber. And that was founded based on a program we had sponsored through the agency and I think NSF at the time too, that taught people basic language skills K through 12. Gen Cyber allows funding to train the trainer and also to train the students at the same time, so you can drive it down. And while not all of it's K through 12, some is. I think the Boy Scouts and Girl Scouts of America had undertaken that, so there are some really interesting camps for kids. And I think you know of some as well from your work.
Right. One place I would definitely look at is, I mentioned the computer science principles AP exam. So this is really, 10th, 11th, 12th grade. But there are recommended curricula that go along with that that can be domain specific. So they can teach some of the principles of computational thinking, for example, but you can do it in the context of security, for example, or in the context of Internet of Things, or pick your area. So folks have developed a number of different curricula that you can pick up relatively easy. So, and teacher training goes along with it, and teaching materials that you can pick up in the high schools, where you pick a particular theme and you teach to the computer science principles agenda, but you do it from a particular point of view. And I know there were people working. Three years ago, when I last looked at this, there were a number of people working on a cybersecurity track within that.
Yeah. And just to riff on that a little bit, again, tying back to the previous conversation, it's so important at that level, I should have said it right off the bat, that funding and time being provided for the teachers. We expect so much of our K through 12 teachers these days, including the horrific. Anyway, so I don't want to go down that road, but we expect them to do everything, and we've got to give them some kind of support, and that means either additional people, additional time, ability to get training themselves. We can't just give them a program because they need to have a way to pull it into the classroom. These programs were aimed at that, the ones that we're talking about, and so more of that support that supports the teachers so the teacher can teach the students is really critical.
Very good.
Thank you.
We're down kind of almost to our last question, and I I got asked before the event to include at least one of our online questions, and our online person who's coordinating our online questions got a question, so I'll take that, and I appreciate everybody else's, and we'll have folks come up afterwards, and I'd be happy to answer questions afterwards, so we appreciate that. Yes?
Yes, thank you. My name's Haley Griffin, and I'm a program associate with the CCC, and I'm helping monitor the online questions. And we have a question that came in from Scott Sellers with the State Department, and he asked, is international collaboration important in networking and security investments? If so, how is it important? If not, why not? And he specifically asked if, Jim, if you could give your input, but of course it's open to everyone. Thank you.
Golly, somebody said at the last panel, it's always good to call out the panelists, so I'll consider myself called out by Scott. So yes, I mean, that kind of international collaboration is always important. So I'll first put on a former NSF hat and speak from that point of view. So NSF has a number of, still has a number of collaborations, specifically in the networking area that are international in nature. So a wireless collaboration with Finland, an internet-based one for disaster recovery with Japan. I know in the past there's been collaborations on networking and IoT with India, so those kinds of international collaborations definitely happen. And generally, the issue of international collaboration, I'm going to take it even outside of networking, is incredibly important. I mean, we've talked about the human elements now, quite a bit, and the OECD, for example, put together a set of AI principles that were adopted by all OECD, every single OECD country, and then a bunch of other countries as well, affirming principles about AI. They're fairly high level, of course, when you get everybody to agree, but it's important and pretty amazing that so many countries could come together and talk about how important it is to be accountable, and fair, and transparent, and it's an example not of specific technical collaborations, but agreeing on the goals and agreeing on the kind of frameworks. And I think that's a really, really important thing to be doing.
Any other thoughts on that question? All right, we have 48 seconds left. So I guess what I'd like to do is say thank you to our panelists for joining us today. And I'm wondering if Anne has an announcement about lunch and other things.
Yes, I want to thank the panels. The two panels this morning are great, and I'm really looking forward to the panels this afternoon. I'm Anne Schwartz, the director of the CCC, and again, I want to welcome everyone here. It's so wonderful to see everyone together in this room. One of the reasons we're here, not on the actual 30th anniversary, is, as we all know, because we've been dealing with the pandemic for the past few years. And I'm really proud to have been able to work with the National Science Foundation at the very start of the pandemic to literally 2 years ago this month, we were able to announce a program for the broad community to keep researchers engaged and active as they were graduating from graduate school to a job market that had literally been pulled out from under their feet at this time of year. And so that program is the Computing Innovation Fellows. We have 140 CI fellows throughout the country at, I think it's 80 different universities, working as postdocs, staying in the academic research pipeline. And so many of you are here today, but big thank you to the National Science Foundation for enabling us to create that program for the community. And we now, before lunch and after lunch, will have posters by many of the CI fellows. So we really do invite you all to go talk with these researchers because they truly are our future. We've got 30 years. We want them to be the ones up here at the next time we do this in 10 years and so forth. So please take the time to do that.